Hi everyone, my name is Miss Connolly. I started making videos for my fifth graders and this one is for them. But my goal is to share it with as many people as possible. So if you are a teacher and you want to use it, feel free to share it with other teachers. If you're a parent and you like it, share it with another parent. And if you're a student and it helped you, please share with another student. Okay, so today for math time, we're going to be thinking about multiplying decimals again. And this time, both factors are going to be less than one whole. Okay, so we see here, our first example we're going to be starting with is 0 and 2/10 times 0 and 4/10. Okay, so in the last videos about multiplying decimals, we thought about estimating. We also thought about what's happening to our factors. If we thought about them as whole numbers, how many times smaller is our factor getting? So how many times smaller should our product be getting? Okay, so we're going to still be doing that. I also have the area model, and we're going to make even more connections to when you multiply a fraction by a fraction, because you know that we can write 2/10 and 4/10 as fractions. Okay, so let's give a story problem context as always. So I have 4/10 of a brownie left over. Okay, so 4/10 of a brownie I have, and somebody came along and ate 2/10 of it. So let's think about if I only have, so this is one whole brownie, if I only have 4/10 of the brownie and somebody comes and eats 2/10 of that 4/10, what do you think about my answer? Okay, I want you thinking about that. What would we estimate this to be? Would it be more than 4/10 or less than 4/10? Would it be a little bit more than 4/10 or a little bit less than 4/10 or a little bit more than 4/10? So we're going to be thinking about it, and we're going to be, as I go through the representation, we're going to be thinking about whether or not it's going to be greater or less than 4/10, the product, and then we'll think about how much. I'm not going to give it away, so let me just stop talking. So anyways, if you recall on a hundredths grid, okay, there's 100 hundredths, and we know that 10 of those hundredths makes 1/10. Okay, so I'm going to shade in 4/10. 1, 2, 3, 4, and they're shaded in the other examples, so we don't have to go through my crazy scribbling. Okay, so there's 4/10 of the brownie that I have left over. Okay, so of this brownie, I have 4/10 left over. And what I'm going to do is I'm going to take 2/10 of that in another color here. So I'm going to take 2/10 of that. So 2/10 is going to be this row and this row. Okay, so this is 1/10, and that's 2/10. So do you think that of the piece of brownie that I have left over, that my product is going to be greater than or less than 4/10? And we can see that it is pretty significantly smaller than the 4/10. Okay, so if I was going to shade in this whole 2/10, I could, but I'm just thinking about how much of a brownie I have left. All right, so what is our product? Well, let's see what's shaded in red and in green, just like we would with the area model with fractions. We're multiplying fraction by fraction. So we have this little piece here is 100th, 200th, 300th, 400th, 500th, 600th, 700th, 800th. So our product is going to be 800ths, and I want to make sure that I write that correctly. If you need help with reading and writing decimals, check out that video that's already been made. So it's 800ths. And one thing I want us to think about is, does it make sense that the decimal goes here? Okay, well, if we started with 4/10 and somebody ate 2/10 of 4/10 of a brownie, we know that's going to be significantly less than 4/10. Okay, then we have this idea to grapple with, like, would my decimal fit here at 8/10? And it wouldn't make any sense because we didn't have 8/10 of the brownie to start with. Okay, so let's make the connection to what we've already learned about when a factor gets, what's happening to the factors. So if I was thinking about these two numbers as whole numbers, I would be able to multiply 2 times 4 and get 8. Okay, but when I have the whole number 2 and I change that factor to 2/10, my factor has gotten 10 times smaller. Okay, and I'm just going to write this down here because we're going to use it in a second. So 2 divided by 10, because you know that this represents division. 2 divided by 10 is 2/10. So this factor got 10 times smaller. Okay, so our product, I'm just going to keep 4 as a whole number here. Our product gets 10 times smaller. Then something else that happened was that 4, the whole number 4, also got 10 times smaller. Okay, because 4 divided by 10 is 4/10. That represents division. Okay, so if both factors get 10 times smaller, we are going to see the products get 10 times smaller again, which is a total of 100 times smaller. So 10 times smaller and then 10 times smaller, the product is getting 100 times smaller. And let's see that relationship with the fractions here. Okay, so yay. We are thinking about 2/10, and I wrote it as a fraction down here. And 4/10, I wrote it as a fraction down here. So numerator times numerator, 2 times 4 is 8. I took 1/10 of 2, 1/10 of 4. So I'm going to do denominator times denominator, 10 times 10, and I get 8/100. Do you see the connection? So if you're stuck and you're like, oh, I'm not really quite sure where the decimal goes, we can think about this as fractions. You can say, well, I'm going to write 2/10 as a fraction. And then you can say, well, I'm going to write 4/10 as a fraction, and then multiply them because you feel very confident with multiplying fractions, and then check your answer. Okay, so let's think about all the things that are going on. We first thought about the size of our product. Okay, it definitely was going to be way less than 4/10 because we were only taking 2/10 of 4/10. Okay, then we did the representation and saw that 8/100 is what happens when we take 2/10 of 4/10 when we're representing it. Then we thought about 2 times 4 as whole numbers, and we got 8. But since 2 got 10 times smaller and became 2/10, and 4 also got 10 times smaller and became 4/10, our product got 100 times smaller. Okay, so each time a factor gets 10 times smaller, the product gets 10 times smaller. And if we do 10 times smaller and then 10 times smaller, that's 100 times smaller. Okay, the last thing that we did was we thought about writing them as fractions, and that helped us. All right, so let's take a look at another one. I have to move my head over here in order to click that. And we are going to be thinking about 5/10 of 3/10. Okay, so same situation as last time. Let's think about a garden this time because you're familiar with that with fractions. So I own 3/10 of an acre of land. This is my full acre, and I've shaded in the 3/10. Okay, I plant tomatoes on 5/10 of the land that I own, only of the land that I own. So if I only own 3/10 of land, am I planting tomatoes on more than 3/10 or less than 3/10? It's going to be less than 3/10. Okay, so another thing I'm thinking about is I know 5 times 3 with whole numbers is 15. So I'm going to be thinking about how much smaller each factor got and how much smaller my product needs to get. But I'm also going to represent, because this is new to us, so I'm going to take 5/10, and I don't own this piece of the 10th. This is my second 10th. Again, I don't own that to begin with. 3/10, 4/10, 5/10. So what do you see shaded in both red and blue? What is 5/10 of 3/10? Well, this is 100th, 200th, 300th. Now I'm going to count by threes. 300ths, 600ths, 900ths, 1200ths, 1500ths. Okay, so I see 1500ths in my representation. All right, let's think about how much smaller each factor got. I see when I have 5, when I thought about it as whole numbers, 5 and 3, I'm going to think about the change from this factor to here and this factor to here. Well, when I go from 5 to 5/10, I know that 5/10 got 10 times smaller than this. So I'm taking 1/10 of 5, and I am taking 1/10 of 3. So 3 divided by 10 is 3/10. So if each factor gets 10 times smaller, my product has to get 10 times smaller and then 10 times smaller again, which makes it 100 times smaller. So I think about this, okay? I have 5 and I made it 10 times smaller, 5/10. I have 3 as a factor and I divided it by 10, it got 10 times smaller. So since I divided both factors by 10, they each got 10 times smaller, my product, the whole number 15, is going to get 100 times smaller. Let's make the connection. Numerator times numerator, denominator times denominator. 5 times 3 is 15. 10 times 10 is 100. And we see 1500ths. You see 1500ths up here? So many connections coming together. So again, what did we do? We represented. Always good to represent. Oh, side note, if you want to hit pause and write down that website, that's where you can get to these base 10 blocks. And all that I did was I took one of these guys and plucked it over here so that I could write on it. Okay, so that is something that you could do if you wanted the representation and you have a computer at home. Anyway, so we thought about the size of the product and what's happening to each factor. So if I think about 5 times 3 as whole numbers, I get 15, but then I have to decide where does the decimal go. If one factor got 10 times smaller and the other factor got 10 times smaller, my product gets 100 times smaller. Then I also thought about it as fractions because I know how to write 5/10 as a fraction. I know how to write 3/10 as a fraction. So I know how to multiply them, numerator times numerator and denominator times denominator. Okay, so there's a lot of different ways that you can get at solving these multiplying decimals when both factors are less than a whole. And let's continue. So we have one last example, then I'm going to give you some to try on your own. All right, so this time I own 4/10 of the land. Okay, I'm probably going to regret moving this. Oh, it's going to scribble down here so we can see what's going on. Okay, I want to take 1500ths of that. Let's delete that stuff up there. I'm going to take 1500ths of 4/10. So let's give it a story problem context. I own 4/10 of this land, and that 4/10 is shaded in. Okay, I want to plant corn on 1500ths of the land. So let's think about hundredths for a second. This 10th here is 10 hundredths. Let me just move my face. There we go. Okay, this 10th here is 10 hundredths going this way, okay, across. And if I wanted to do 1500ths, I have to think for a second. The second row, if I was going to shade across here, that would be 20 hundredths. So let me do the 10 hundredths. And if I did a whole nother 10th, that would be 20 hundredths. And I don't want 20 hundredths, I want 15 hundredths. So what I'm going to be thinking about here is shading in half of the next 10th to make 15 hundredths. Okay, so I know that doesn't necessarily look like I really shaded that in, but just stick with me. So let's think about how much is shaded in if I put corn on 15 hundredths of 4/10. So I have 1, 2, 3, 4 hundredths, 4 full hundredths shaded in. And then I have half of this hundredth and half of this hundredth. Well, interesting. That makes 1 full hundredth. So there's my 5th hundredth. And then over here, I have half of this hundredth and half of this hundredth, which is my 600th. Okay, so my head just keeps getting in the way of all of this. 600ths is what I see in my representation. But let's think about all the different ways we can think about this. Okay, so I know 15 times 4. Ooh, made that really big. All right, so 15 times 4, I'm going to think about these as whole numbers. And I know that that's 60. When I go from 15 to 1500ths, let's write it as a fraction. How much smaller is my factor getting? You can see I'm dividing it by 100, right? So I know that my factor has to get 100 times smaller. Or sorry, my factor got 100 times smaller, so I know my product has to get 100 times smaller. And then what also happened here is 4, the whole number 4, to go from 4 to 4/10, I divided by 10, which means it got 10 times smaller. So, what's going on here? Well, if I was going to take 60 and make it 100 times smaller, I would get 60 hundredths. Okay, so when 15 got 100 times smaller, my product got 100 times smaller. Okay, but then this factor also got 10 times smaller. So my product actually has to get another 10 times smaller. So if you think about it, 10 times, I'm trying to get my hand in here, 10 times smaller. I'm opposite, so I can't do that. So it got 10 times smaller, 100 times smaller, and then I had to make it 10 times smaller again. So it got 1,000 times smaller altogether. So can we see that down here? 15 times 4 is 60. Numerator times numerator. 100 times 10 is 1,000. Can you see how it became 60 divided by 1,000? 1,000 times smaller. So how do we write that as a decimal? To the thousands place. Here it is, 60 thousandths. But Miss Conley, you got 600ths up here. Well, boys and girls, you know that 60 thousandths and 600ths are equivalent to each other. Okay, they're equivalent decimals, equivalent fractions. So this situation was different for us. It's one we haven't seen before. When our this factor got 100 times smaller and this factor got 10 times smaller, that made our product 1,000 times smaller. Okay, because it had to get 10 times smaller, 10 times smaller, and 10 times smaller again. So 10 times 10 times 10 is 1,000, and that's why it's getting 1,000 times smaller. So let's take a look at the ones that you are going to try on your own. You are going to be thinking about if you have 2/10 of a brownie and someone eats 8/10 of the 2/10, how much of the brownie did they eat? Let's say for this one, you have an animal that goes 3/10 of a mile an hour. It's a real slow animal. And they do that for 25/100ths of an hour. How far do they go? Okay, then I want you thinking about if you own 4/10 of a piece of land and you plant corn on 6/10 of that, how much of the land, the full acre of land, is planted with corn? Okay, you are going to try to pull up that website if you want to use a representation. Okay, go back, rewind, write it down, type it in. If you want, you can think about multiplying these as if they're whole numbers and then placing the decimal based on how much smaller the factors got. Or you can be thinking about what is a reasonable size for my product? What makes sense? Where should the decimal go to make sense? And I have a surprise for you. In the next video, I'm going to teach you how we know where to place the decimal each and every time. And don't be mad, but I had to make sure you understood what was actually happening. And then I'll teach you the procedure. As always, okay, talk to you later. Bye.